Hi, I'm Ellie and Caitlin's behind the camera, and we've collectively taught in the New York City public school system for 22 years, and we're really lucky to be co-workers. We asked students what's the best way for us to get from our third floor classroom to the public park across the street. Right away, students were debating whether they should run down the stairs and try to go past security versus taking a zip line from the window down to the park. Students were quick to connect those ideas with the right triangle trigonometry unit we had been working on in class. Most of our lesson planning time was spent thinking about how to give the information and how much information we should give to students in order to solve the problem. Initially, we thought we should give each group different information to try to push them to think through that question in a specific perspective, but then we thought we would just give the students time to brainstorm what information we could reasonably gather, then gather that information, and then give them the time and the space to answer the questions while working in groups. So the students were able to say that we could find the height of the building by asking the assistant principal and using a clinometer to find the angle of depression. The day before, we had made a clinometer and warned the assistant principal that he might be getting a phone call from us. So from a quick phone call and a measurement, they were off solving the problem. And students were able to find their own solution pathways, and it actually led to a greater diversity in problem solving than we had even expected. While they worked, we circulated the room and monitored their work and picked 3 groups to present to the class. The first group had used tangent to find the leg, and then that Pythagorean theorem to find the hypotenuse. Then the other 2 groups, one had used sine and one had used cosine to find the hypotenuse directly. We'll be the first to admit that we used to teach this unit in a super boring way. We used to teach the trig ratios all at once, all 3 of them, and they seemed interchangeable and totally disconnected from the Pythagorean theorem. This year we made an effort to really focus on tangent. We taught them all 3 ratios, but focused on tangent. And then today was one of the first days that students even used sine and cosine. Also in the past, our real world questions would have been questions from the state exam about hot air balloons and sailboats, not the real world that our students live in. Now we try to embed their learning in the world around them. In past years, at some moment in our trigonometry unit, we would mention explicitly to our students that the cosine and sine of complementary angles are equivalent. We would say, this is a really important fact that you need to memorize for use on your state exam. But in today's lesson, the sequence of work that was shared led to a student noticing that the cosine of 80 degrees was equal to the sine of 10 degrees. And they questioned, is that a thing? And so we gave the whole class the time and space to work together and to play with pairs of numbers to see if there was any pattern they could find. And there was a group that quickly delighted in figuring out the thing that we were going to teach them as a fact. And so that was the most interesting moment, and it came from them.